just do this in Desmos, okay? No offense, but by question 16, you should have realized you're definitely in the easy module, and you're in the easy module because you are not that good at math. So let the calculator do the math for you, okay? I can show you how to do it at the end, but you just please, even if you think you know, at least test it out, right? So we have to shift this graph 2 units down. So I can do that. I can put the f of x, but just to show you, this is a place where we can kind of, leave it off. So f of x equals 7x to the third. So to the third. And we get some weird looking graph, that's fine. But now just pay attention to what they want, right? They want us to shift it 2 units down. So I know it sounds a little weird just to say it, right? They say in the xy plane, which is the graph of g of x, which is a new thing, is the result of shifting the graph of y equals f of x, which is the thing we've been talking about, just the 7x to the third, down 2 units, meaning it moves down. So what is going to define g? Again, just try out your answers. So we could go through all of them. So just to show you 7 halves, I'm not going to go through all of them, but I'll show you one wrong one here. So this is not moving down, and we can zoom in and we can see what's happening here, right? If it were moving down, that y-intercept, that place where it crosses the y-axis, that's usually a great place to look. It would move down, right? The red and the blue would shift. The red and the blue would still look the same as like the same basic shape, but the blue, since that's our second one, our answer would have moved down too. It didn't. It stayed in the same spot. It's a different shape in some other way, but it's not what we want. So that's wrong. Now, some of you are going to know from school that what happens is in order to shift something down, you have to subtract the number from the equation as a whole. So 7x to the third minus 2 is going to give us what we want. So if I zoom out a little bit, notice we have the same basic shape, but notice what happened. The red intersects the y-axis at 0, but now the green, which is the shifted version, is intersecting at -2. So it shifted from 0 down to -2, down 2. So there you go. That is the proof. And again, like I said, some of you just know that if I want to shift down 2, I take, here, let's do it like this way. We take our f of x, so f of x, and then we shift it down 2. It's going to become g of x, which will be f of x minus 2. And that's why it's so easy to move things up and down, is you just take whatever equation you have and you just put it at the end. But there will be cases where it does not behave that way. Okay, a big one is circles. Okay, circles are not going to behave the way you think when you move them up and down. So this is why, no matter how confident you are that choice D is right, you're in the easy module for a reason. You're in the easy module because your math instincts are not very good. And it does not take very long to just take your answer and throw it in Desmos and look at it and see with your eyes, did this thing move down? Yes, in this case, your instinct was right. But the reason you're in the easy module is there are so many cases where your instinct was wrong and you don't know it. You'll know it when you go over the test. And that's why we use our bookmarks. But here, you've got to get into the habit of knowing when you could be wrong and using whatever tools we have in the app and on our scratch paper to make sure we are not making a mistake, because this is gettable. It's really easy. If you do make a mistake here, it could have been saved by just going to the calculator, seeing it with your own eyes, and letting the calculator prove your answer to you. As always, we might have good instincts. We always want to prove them with real math and real visuals.